right now, there are people out there paying like hundreds of dollars to have highly purified fish DNA injected directly into their faces.
Yeah, the famous salmon sperm facials.
Exactly. And the aesthetic clinics selling these treatments, they promise that it's completely invisible to your immune system. They claim it's just this natural, universally safe way to regenerate tissue.
Right.
But if you dig into the research, specifically the cellular biology paper from 1999, there is a really stark warning hidden in there. This DNA is, well, it's not invisible at all.
No, not even slightly.
Right. And if you happen to have an autoimmune disease, getting this trendy treatment might just kick off a biological war inside your body.
It's a massive contradiction, honestly, between the clinic marketing
Hmm.
and, well, fundamental immunology.
Hmm.
We're looking at this landscape where the desire for, glowing skin or pain-free joints is violently colliding with the realities of complex medical conditions.
And that collision is exactly what we are navigating on today's deep dive. So
Right.
welcome. We've got a really diverse stack of sources on the table for you today.
Yeah, quite a mix.
We're pulling from safety guidelines issued by these high-end aesthetic clinics on Harley Street, clinical trials looking at joint pain and hypertrophic scar treatments, and some incredibly dense immunological research published in the Proceedings of the National Academy of Sciences.
The PNAS study, yeah.
Right. And our mission for you, the listener, is to synthesize all of this to answer one highly specific, critical question. Can polynucleotides be safely administered to patients taking systemic, immunosuppressive, or anti-rheumatic biologic therapies?
Which is arguably it's the most important question in regenerative medicine right now. Because when you introduce foreign genetic material into a body whose immune system is either misfiring, which is literally the definition of an autoimmune disease,
Right.
or is being artificially suppressed by heavy targeted medications, you're taking an immense biological gamble. You are directly engaging with the body's main security system.
So let's start with what these molecules actually do when they enter human tissue. Because, looking at the sources, the clinical results are genuinely impressive.
They really are.
So polynucleotides, or PNs, they're highly purified DNA fragments, and our sources indicate they're usually derived from the gonads of trout or salmon.
Right, the fish DNA.
Yeah. And they're doing some heavy lifting. There's a randomized double-blinded study from Thailand in our stack showing that injecting PNs into hypertrophic scars, those thick, raised, really angry scars, it actually reduced scar pigmentation and flattened the tissue even better than traditional corticosteroid injections.
Yeah, and they are also rivaling traditional hyaluronic acid for treating knee osteoarthritis.
Yeah.
But to understand how they achieve this, we have to look at cellular metabolism.
Okay, lay it on me.
So polynucleotides work by essentially enriching the extracellular environment. The cells basically use these degraded DNA fragments, specifically the purines and pyrimidines, as raw building blocks.
So wait, the cells aren't just sitting there bathing in the fish DNA, they're actively consuming it.
Well, they're salvaging it. Creating new DNA from scratch is a highly energy-intensive process for a cell. It requires a lot of metabolic resources.
Makes sense.
So when you inject these degraded fragments, you are providing the cell with a shortcut. It's called the salvage pathway.
The salvage pathway.
Right. The local cells, particularly fibroblasts, they just scoop up these free purines and pyrimidines and use them to rapidly synthesize their own new DNA and RNA.
Oh, wow.
Yeah. And this massive energy savings fuels fibroblast proliferation, which leads directly to, increased collagen production and tissue repair.
Okay, I see why the aesthetics industry jumped all over this. You're essentially delivering pre-cut lumber to a construction site so the builders can just work twice as fast.
That's exactly it.
And the key selling point the clinics use to convince people this is perfectly safe is the term non-immunogenic. They claim it won't trigger an allergic reaction or an immune response.
Right, because of the purification.
Yeah, the logic is that their purification process uses high heat and aggressive filtration to just completely strip away all the proteins from the fish DNA.
And they emphasize the removal of proteins because proteins are typically the antigens that trigger the body's immediate allergic alarms, right? Like what you would see in a severe anaphylactic fish allergy.
Right, right. So the analogy that comes to mind is stealing a foreign, unauthorized car and trying to sneak it into a highly secure military facility.
Okay, I like where this is going.
If you grind off the VIN number, strip the license plates, and completely strip away all the identifiable paint, which represents the proteins, you theoretically make the car invisible to the security guards at the gate. It's just a generic chassis. It slips right in unnoticed.
And that is exactly how the clinics are selling it to you. But basic cellular biology dictates a much more complicated reality.
The plot thickens.
Yeah, because the security guards might not recognize the specific license plate, but they absolutely notice when a strange, unidentified chassis just gets parked in the middle of their secure base.
Okay, hold on. You're saying basic cellular biology contradicts the Harley Street marketing? Because this is where you threw a massive scientific curveball into our research stack.
I did, yeah.
You brought in this 1999 study from PNAS, the Proceedings of the National Academy of Sciences, that essentially just blows up the whole invisible narrative.
It shatters it completely. So the PNAS study looked at what happens when you introduce double-stranded DNA into the cytoplasm of a non-immune cell.
Like a normal skin cell.
Exactly. Think of a regular skin cell, a fibroblast, or a thyroid cell. Under normal, healthy conditions, double-stranded DNA belongs strictly inside the nucleus of a cell, not floating around in the cytoplasm.
Right, the nucleus is the vault.
Yeah. So when the researchers introduced a double-stranded DNA fragment, even one incredibly tiny, like just 25 base pairs long, regardless of its sequence, and completely devoid of any proteins, the cell instantly recognized it was out of place.
Wait, how does a regular skin cell even know what to look for? I mean, it's not a white blood cell.
It's because all cells have cytosolic DNA sensors. When they detect naked DNA in the cytoplasm, it acts as a universal danger signal.
Yeah, wow.
The cell essentially assumes it has been infected by a virus. And in response, the study showed that the cell directly activates its major histocompatibility complex, or MHC class I and class II genes.
Okay, so MHC molecules, those are literally the display windows of a cell.
Right. That's a good way to picture it.
It's how a cell takes a piece of its internal material, holds it up on its surface, and shows it to the passing T cells of the immune system to prove whether it's healthy or infected.
So you're saying the naked DNA directly forces the cell to build more display windows?
Not just build more windows, but actively stalk them.
Really?
Yeah, when the cytosolic sensors detect the DNA, it triggers this whole cascade. The cell increases the activity of proteasomes, which are like cellular shredders that chop up internal proteins into tiny peptides.
Okay.
And it also upregulates transporter molecules, known as TAP, which basically shuttle those shredded peptides into the endoplasmic reticulum to be loaded onto the MHC molecules. So the skin cell is temporarily turning itself into an alarm beacon, like it's forcing the immune system to come look at what's happening inside of it.
Exactly. It temporarily transforms a normal, non-professional cell into an antigen-presenting cell. It causes a localized, highly specific inflammatory spark.
Now, for a healthy person, I guess that spark just tells the body, hey, pay attention to this area, send some resources, build some collagen, repair this tissue. Like the mild inflammation is the entire point of the aesthetic treatment.
Precisely.
But, and here's the massive but, if a single snippet of DNA can light this localized inflammatory spark, what happens when you introduce that into a body where the immune system is already a raging fire?
Yeah, that's the real issue.
Because this is exactly why ethical aesthetic clinics are drawing a hard line in the sand.
And you see this when you look at the practical source material. The guidelines from aesthetic clinics like Rejuva London, Define Clinic, and the Harley Academy, there is a universal, non-negotiable theme. Active autoimmune diseases, immunosuppressive therapy, and being immunocompromised are listed as strict, absolute contraindications.
Meaning they will outright refuse to treat you.
Exactly.
And based on that cellular mechanism you just broke down, the Harley Academy guidelines highlight a dual threat for these patients. Let's look at the first threat. The risk of triggering an unpredictable systemic immune response, sometimes referred to as Asia syndrome.
Right, Asia syndrome.
Which stands for autoimmune inflammatory syndrome induced by adjuvants.
Yeah, and to really understand Asia syndrome, you have to understand what an adjuvant is. In vaccines, adjuvants are compounds purposely added to enhance the immune response to an antigen.
They're the chemical alarm bells.
Exactly. Because polynucleotides trigger that cytosolic DNA sensor and upregulate MHC expression, they act as localized inflammatory catalysts. They behave exactly like an adjuvant.
So if a patient's immune system is already primed to attack their own body, which is what rheumatoid arthritis or Hashimoto's is, their threshold for an immune response is already dangerously low.
It is hanging by a thread. Introducing a foreign DNA fragment that causes local cells to suddenly present antigens on their surface acts as a major trigger.
Yeah.
That's like, well, imagine setting off a loud car alarm in a neighborhood where the police are already heavily armed and totally on edge. It triggers a massive disproportionate response.
Oh, that's a scary thought.
The hypervigilant immune cells rush to the site, the cellular communication gets completely scrambled, and you can trigger a massive, unpredictable autoimmune flare-up that extends way beyond the injection site.
Okay, so the first risk is waking the immune system up and causing a massive flare. But wait, if I'm a patient managing a severe autoimmune condition, I am likely on a heavy biologic medication that is purposely suppressing my immune system. Doesn't that create an entirely different problem?
It absolutely does.
Like, if this aesthetic injection breaks the skin barrier to deliver the DNA and my immune system is artificially suppressed, I don't have the standard cellular defenses to fight off an actual bacterial infection at the injection site.
You've pinpointed the second major threat right there: severe, persistent infection risk. And this requires looking closely at how those biologic medications actually function.
Right, because they aren't just general dampeners like older steroids, right?
Oh, not at all. They are highly specific molecular interceptors.
Because our sources detail patients taking antirheumatic biologics that target specific pathways like TNF-alpha or IL-6, and instead of using the old sniper metaphor that gets thrown around, these biologics act a lot more like signal jammers, right?
Signal jammer is a much more accurate description, yeah. So TNF-alpha and IL-6 are cytokines. You can think of them as the chemical text messages the immune system uses to shout out orders like attack this joint tissue or ramp up the inflammation here.
Got it.
A biologic medication, which is typically a synthesized monoclonal antibody, circulates in the bloodstream and binds directly to that TNF-alpha molecule before it can reach its receptor.
So it intercepts the text message?
Exactly. It intercepts the message, so the immune attack dogs never get the order to strike.
Which is miraculous for stopping the autoimmune disease from destroying a patient's joints.
It's life-changing.
But if a needle pushes bacteria into the deep tissue of the cheek during a polynucleotide treatment, the local immune cells might try to send out a TNF-alpha text message calling for backup to fight the bacteria, and the biologic medication will jam that signal too.
Exactly. The bacteria can just proliferate unchecked. The risk of a persistent deep tissue infection, or even a systemic one, becomes unacceptably high because the body simply cannot mount a localized defense.
Wow. This makes the stakes incredibly real for you, the listener. If you're a patient managing a chronic condition, an aesthetic injection isn't just about glowing skin, it's a direct negotiation with your compromised immune system.
That's a great way to phrase it.
But I have to ask, is this a permanent ban for literally everyone? Our stack of sources includes a review from the journal Frontiers, specifically evaluating aesthetic interventions in immune-mediated diseases.
Yes, the Frontiers Review.
And they suggest that some procedures can be relatively safe if a patient is in a documented, stable state of remission. So if a patient's disease has been completely quiet for, say, 2 years, and their biologic medication is keeping them symptom-free, can they get a polynucleotide injection?
So the Frontiers Review does introduce that nuance. They note that passive treatments, like certain pure hyaluronic acid fillers, might be used cautiously in stable patients.
Okay, but polynucleotides aren't passive.
Right. They are biostimulators. They are fundamentally active. The critical complication is the mechanism of the biological truce.
Meaning what, exactly? Like, if the biologic medication is working perfectly, the signal jammers are intercepting every rogue text message, the autoimmune disease is asleep, could injecting a polynucleotide override the biologic medication?
That is the nightmare scenario keeping practitioners awake at night, and it ties directly back to that 1999 PNAS study.
Oh, the alarm beacon effect.
Right. The fear is that the localized adjuvant effect of the polynucleotides, the sudden forced upregulation of those MHC display windows and the aggressive recruitment of T cells to the injection site, could break the fragile truce the biologic has established.
So the biologic is trying to enforce a cellular blackout, and the polynucleotide injection is dropping a literal flare into the tissue.
Exactly. A flare that upregulates entirely different pathways that the biologic might not be jamming. The immune system is hypervigilant. You drop a strange genetic package into the tissue, the cells start displaying new antigens, and suddenly the peace is broken. A
Wow.
localized reaction can rapidly escalate, overriding the medication and triggering a systemic flare-up.
It seems overwhelmingly conclusive. Like autoimmune disease plus foreign DNA equals disaster. You shouldn't be messing with regenerative DNA injections if your immune piece is bought and paid for by a biologic drug.
That's the consensus, yes.
But there is one final source in our stack, and this piece of research completely flips our understanding of how nuclear material interacts with the immune system on its head.
Yeah, this is where it gets truly fascinating.
Mhm.
It introduces the paradox of tolerance.
Okay, let's unpack this. Up to this point, we've established that naked genetic material triggers an alarm. Our sources highlight a compound called poly-IC, which is a synthetic double-stranded RNA.
Right.
And it's intentionally used in medical research as a potent vaccine adjuvant. Like, when injected, it deliberately mimics a severe viral infection to aggressively spike inflammation, which confirms everything we just discussed.
It does.
But then we have this incredible study on lupus-prone mice. Now, lupus is a severe autoimmune disease where the body literally attacks its own tissues, often aggressively targeting the DNA and the nucleus of its own cells, right?
Yes, it's devastating. It causes lupus nephritis, where immune complexes deposit in the kidneys and destroy them.
Okay, so what happens when researchers purposely injected more nuclear material, specifically nucleosomal histone peptide epitopes, into these mice?
Well, logically, you would expect a lethal flare-up. I mean, you're handing a hyper-aggressive immune system the exact antigen it is already obsessed with destroying.
Right, adding fuel to the fire.
But the researchers altered the dosage dramatically. When they administered subnanomolar doses like infinitesimally small amounts of these specific histone peptides to the mice, it did not cause the expected autoimmune explosion.
Wait, it didn't?
No, it induced profound immune tolerance.
So the immune system just stopped attacking the kidneys. How does giving them the target make them stop shooting?
It fundamentally altered the T-cell population. The ultra-low dose of the histone peptides didn't trigger the cytosolic danger sensors in the same way. Instead, it generated a massive expansion of a specialized subset of cells called Treg cells, or regulatory T cells.
Oh, I've heard of these. So if the other immune cells are the attack dogs, the Treg cells are the handlers physically pulling back on the leash.
That is a perfect analogy. And they use a very specific chemical mechanism to do it. These newly generated Treg cells started migrating to the inflamed kidneys and producing large amounts of a chemical called TGF-beta.
Okay, what does TGF-beta do?
It's a powerful anti-inflammatory cytokine. It physically binds to the receptors on the surface of the aggressive, tissue-destroying effector T cells.
So it intercepts them.
Better than intercepts, it paralyzes them.
Hmm.
When TGF-beta binds to the aggressive T cell, it triggers a signaling cascade inside that cell that forces it to stop proliferating and stops it from producing inflammatory toxins.
That's wild.
The Treg cells essentially walked into the war zone of the kidney and issued a localized biological ceasefire order. It halted the progression of the lupus nephritis and actually restored the mice to a normal lifespan.
My mind is slightly blown. Is this mechanically similar to how an allergy shot works?
Yeah.
Where, like, if a patient is deathly allergic to bee venom, an allergist will inject them with a microdose of that exact venom over and over again.
Very similar, yeah.
It's too small to trigger anaphylaxis, but just enough to force the immune system to generate Treg cells until it learns to tolerate the venom.
The underlying principle of utilizing a subthreshold dose to induce Treg-mediated tolerance is remarkably similar. By introducing just the right molecular fragment at an incredibly low dose, the researchers bypassed the alarm systems and directly activated the body's natural peacekeepers.
Which proves that the immune system's reaction to nuclear components is not just a binary on switch for inflammation.
Exactly. It is highly dialable. It depends entirely on the dosage, the exact structural sequence of the molecule, and the microenvironment it's introduced into.
Right.
DNA and RNA fragments can act as devastating adjuvants, but depending on how they are engineered, they can also act as the ultimate off switch.
Now, we have to be incredibly clear for you listening. The injectable polynucleotides currently sitting in aesthetic clinics are generalized, purified fish DNA aimed at tissue repair. They are not the targeted subnanomolar histone therapies used in that lupus study.
Oh, not even close. Commercial polynucleotides are administered at much higher doses, specifically to stimulate that local inflammatory regenerative spark. They are completely different tools.
Which brings us back to our core mission. We've gone from Harley Street marketing to 1999 cellular biology into the complex signal jamming of biologic medications, and finally to cutting-edge lupus research in mice. Let's synthesize this and answer the question you came here for.
The big question.
Can polynucleotides be safely administered to patients taking systemic, immunosuppressive, or anti-rheumatic biologic therapies?
Based on the totality of the current clinical guidelines and a deep understanding of the underlying cellular mechanisms, the answer is a definitive no.
Yeah. The risks of unpredictable immune flare-ups, where the biostimulator acts as an adjuvant and overrides the biologic signal jammer, and the severe risks of deep tissue infections in a suppressed system are simply too high.
Way too high.
It remains a firm, absolute contraindication in the medical aesthetics community. If you are on these medications, you have to prioritize the stability of your immune system over any localized tissue regeneration.
The clinical reality really demands extreme caution. But looking at the trajectory of the science, I do want to leave you with a final thought to mull over, building entirely on the mechanisms we uncovered in that lupus study.
Ah, the paradox of tolerance.
Exactly. Its specific sub-nanomolar nuclear fragments can be used to intentionally generate Treg cells and calm down a raging autoimmune disease in the kidneys. Could the future of regenerative medicine involve engineering bespoke synthetic polynucleotides?
Oh, like a treatment that doesn't just avoid the immune system, but actively manages it.
Imagine the next generation of these injectables. Instead of a general tissue repair serum that you have to strictly keep away from autoimmune patients, what if it's designed specifically for patients on biologics?
I see where you're going.
A synthetic polynucleotide engineered to provide the raw purines and pyrimidines for tissue repair while simultaneously releasing targeted peptide fragments that generate localized Treg cells.
A localized dose of tolerance that physically repairs a damaged arthritic knee while simultaneously paralyzing the aggressive immune cells trying to destroy it. We would go from treating these patients as contraindicated outcasts to actually designing the ultimate therapy around their unique biology.
It shifts the entire medical paradigm from avoid at all costs to targeted immunomodulatory healing.
That is the kind of science that redefines medicine. To you listening, thank you for joining us on this deep dive. Keep questioning the underlying mechanics of the trends you see, and remember, just because something is branded as a simple beauty treatment doesn't mean it isn't fundamentally interacting with the deepest, most complex parts of your cellular biology. We'll catch you next time.